Hey friends, there's something new from our sponsor Text Control. Their new product, DS Server, provides document services out of the box for all platforms and languages. Whether you want to integrate document creation, editing, sharing, or collaboration into your web app, DS Server provides the back-end technology to integrate that professional document processing. For example, using DS Server, you could integrate an MS Word compatible document editor into pure JavaScript, Angular, or an ASP.NET Core application. You can create PDF documents using Web API calls or even request electronic signatures from end users. DS Server is also hosted on-premise in your infrastructure or with your cloud provider, such as Microsoft Azure. And you can test DS Server without downloading anything. Create your first DS Server application in minutes by requesting a trial token on their dedicated website at dsserver.io. That's DSSERVER.io. Hi, I'm Scott Hanselman, and this is another episode of Hansel Minutes. Today I'm talking with David Weston, the Partner Director of OS Security at Microsoft. How are you, sir?
Doing really well. Happy to be here, Scott.
Thanks for hanging out.
Yeah, absolutely.
I'm coming at this from a person who has a family full of computers. I got all kinds of computers. I got old ones and new ones. I got gaming PCs that my son has built. He's got like an AMD something. My wife's got a Surface laptop that she bought with her own money. I've got a full-on gaming PC that I bought that I put together. I got AMD and Intel in my house. I got Surface. I got a Lenovo. And I've also got my parents and my family asking me about Windows 11.
Sure.
And I'm an early adopter, so I'm like, yeah, let's go. And so I run this PC health app that everybody's talking about, and it tells me that 80% of my machines are allowed to upgrade. But one that I was kind of surprised about, which was like the one I spent all this money on, was a 7th gen Intel, and it was like a 7900 and something. And like from a pure perf benchmark perspective, it's a good solid 5 or 6 year old machine. Why can't that upgrade to Windows 11?
So I think the goal with Windows 11 is to create a modern experience. And a modern experience has a couple of different factors. Obviously, you want it to be secure. You want it to be performant. You want it to be highly reliable, right? You just don't want to think about it. You want to use this machine and everything is great. Mm-hmm. And so the CPU bar tries to balance those three things in a sort of an equal way. So you're talking about a particular CPU. For example, you have a 7th gen. It just flies at gaming. It's amazing. It also has the security features, but does it have the drivers? Does it have the reliability statistics that we publish? Well, it's not checking that thing. If it can't check all three of those boxes, then while we still think it's a great machine, it can still grant a great operating system with Windows 10, it is not meeting the experience we think we owe to our customers. And that's really how we set the bar. Now, obviously, that's challenging. There's a lot of subjective opinions on where that bar should be. I think, people even smarter than I went through the data and analytics, looked at reliability and crash numbers, looked at performance testing, not on one machine, right? Like on millions of machines, worked with each of the silicon vendors who all, by the way, have a very similar viewpoint. And then obviously the security features factor in. So we made that decision based on what we think is going to provide the optimal experience for the customer, giving them the right operating system that can take advantage of that. Now, does that mean, you're going to be less secure? No. On Windows 10, you can turn on the vast majority of these features. You can still game for a very long time on Windows 10. We will be supporting it for the future. There will be driver updates. And so while we understand, and in a way, it's great to see how much people care about the Windows experience, at some point, in order to deliver our vision, we had to pick a line. And this is the line we landed on. And it was data-driven. It's based on analytics. And this is where we're at today.
Okay, cool. So let me see if I can paraphrase some of that to make sure I understand.
Sure.
So simplistically, at the beginning, I was thinking it was about perf because I'm like, this is an i9.
Sure.
I got 64 gigs of RAM. I'm listing specs. Look at my big hard drive. Look at my great video card. But we're talking about low-level specific chipset features, things about secure boot, trusted boot. What is the thing? VBS, virtualization-based security. All of those things are specific features like in the chip itself or in and around the support system of the chip. And in this case, a 7th gen is what is that? 7, 8, 9, 10, 11, 4 or 5 generations behind. And that's not necessarily just Microsoft supporting it. You said that there's vendors, the silicon vendors have drivers, microcode updates
That's
that
right.
they have to do, they have to
That's
manage
right.
as well. Okay.
Yep. And all of that factors into the experience. So again, there's many folks who are saying, is it this one thing? Is it this? No, it's the experience overall. And that's our role in this, is to curate an experience that's going to meet customer expectations using data to do that.
So you mentioned that I can turn a lot of these features on myself. So
That's
on
right.
the one machine I couldn't upgrade, I went into Windows Security, and I realized that all this time, like I'm saying, I want to upgrade to Windows 11. I actually had never turned on VBS, and I'd never turned on memory integrity. And then when I tried to do those things, it turned out I was on a GDR. Is that the term? What is the old file system for GPT?
Well, GPT is usually the newer boot file system
MBR.
for UFI. So you're on MBR, yeah.
I was on MBR. So I was actually, so it turned out this was a machine that I'd been upgrading for years, since pre-Windows 10. So that disk itself didn't have the right amount of support for GPT, the newer partitioning table. So I ended up turning on basically everything that I could, which got me certainly more secure, right? So as a Windows 10 machine that I never thought about any of these features before, I'm better off now, right? That I've got VPS on,
Absolutely.
the newer file system. I made it secure boot. I also BitLockered it too.
Absolutely. And that is, one of the key learnings was in Windows 10, we made many of these things optional. And I think many people take the stance, if Microsoft didn't turn it on, I probably shouldn't muck with this, right? And in a way that makes security very exclusive, right? It's almost like saying, in order to game, you must be able to overclock. Like, not everyone's going to go into the BIOS and do XMPP and those kinds of things. And many people, myself included, just says, it's probably pretty safe. I don't do it. You know why? Because I don't want to debug what goes wrong. I want to play Warzone and I want to go have fun with my friends. I don't want to debug that. And so security is actually quite similar, which is we've had these great valuable things. Not everyone's been to take advantage. So one of the goals with Windows 11 is to, in a way, democratize this, make sure that everyone on the operating system has those capabilities, can be protected, and do so in a transparent way where you're not trading off performance and reliability to an undue extent.
That's an interesting analogy that you made there, because I know that, like, my son definitely got the XMPP and did a bunch of overclocking, but he hasn't thought about turning on any of the security stuff. So, seems like some aspects of the enthusiast community, and I'll take my son and call him an enthusiast, are tweaking fan speeds and using specific processor cores more than others and all that kind of stuff. But they're not turning on all these great security features that are available to them, because that's just not the kind of enthusiast that they are.
That's right. And so one of the reasons we created the Windows Security app, even back in 10, was that was our first foray into making this more accessible. You could search it. It was a modern sort of acrylic-based app. It has all of the great UI, and it's very simplistic to use. There is, the equivalent of overclockers in the security community, if you can imagine that. We've had apps like Emmet, Enhanced Mitigations Experience Toolkit. We've built much of that into Windows through a feature set called Attack Surface Reduction. So there is the equivalent of overclocking in the security community, if you couldn't believe that.
Interesting. Okay, so it makes sense that he's one flavor of enthusiast, but he's not a security enthusiast yet.
I know all of the overclock hacks on all of the operating systems out there. That's where I come from.
So you're both. You actually do both. You're like, how can I lock it down and make it faster?
Yeah, absolutely. Yeah.
Okay.
Yeah, I love this stuff.
Okay, so then by default, though, a lot of people, like non-technical parent, my parents will probably just, whenever their computer ages out, 5-6 years down the road, they'll pick up a new PC, and that will have all of this out of the box.
That's right.
So all of these overclocking security features, like VBS and on, they'll just be on by default, and they don't have to worry about it.
Yeah, that's right.
Okay. What about that feeling of being like left behind, though? It's kind of like they just want the shiny thing. Ultimately, they have to make a decision there. I don't want to make like waste. Right. I don't want to throw away a perfectly good computer. It's kind of a difficult decision for me.
The great news is we've got an amazing operating system in Windows 10 that has, especially on the security side, many of the features. So we don't think people will be left behind. We published a lot of documentation on how to make 10 very similar to 11 from a security perspective. And so I think, at some point there's a new operating system, and there's got to be, in order to make a new experience, I think there has to be at least a decision point there. I wouldn't characterize that as left behind. I would say this is something that, folks to have to look forward to when they get their new machine, if they don't have qualifying hardware.
Actually, that makes me think about Xbox One and Xbox One X. Right?
Sure.
There was a generational moment there,
Yep.
and they came up with smart delivery, which meant that you'd have one disc and you'd get the right game for the right system. And there was a console generation, but people's Xbox Ones, my son's Xbox One, is still working just fine.
Yep.
And he hasn't really felt left behind because basically everything can run, just not with full settings on.
Absolutely.
Same thing applies here from a security perspective.
Yeah, I still have machines running 10. I don't feel less secure on those machines. Obviously, I've had to do a little more elbow grease, and that's one of the value propositions of 11. But it's still a great operating system.
Yeah. So there's UEFI, which we'll talk about in a second, but there's also the secure boot and trusted boot. And I'm having trouble figuring out what's the difference between secure boot and trusted boot.
Yeah, secure boot will be where you are validating through signing certificates and signing keys that all of the components of boot are either from your platform vendor or signed by Microsoft. And you can actually, in many implementations, you can set your own keys up. You have the ability to do your own PKI. That's, again, talk about overclocking. That's for the hardcore only. But you can sort of set up your own PKI to make sure that every piece of code is trusted and signed by who you want it to be signed by. That's secure boot. Trusted boot adds an additional layer where not only do you have the signing infrastructure, but you get additional measurements, which are provided into things called PCR or PC registers. And that's through a combination of the TPM and CPU support. And then the operating system can use those measurements to take action. So for example, if you ever saw the dreaded BitLocker recovery screen, that's usually because a component on your system that was previously measured in and was one of the prerequisites for unsealing your BitLocker key from the TPM, that's changed, and the operating system is saying, hey, something has changed. If that's unintended, if potentially a piece of malware or some other physical modification happened, we want you to acknowledge that that's safe by putting in your recovery key. And so that is a piece of what measured or trusted boot along with secure boot give you.
That's interesting. That reminds me, I used to work in banking, and we would check for name and password when you log in, and you'd go about and do your thing. But then if you did something that behaviorally seemed weird, even though you're already logged in, we'd go, hang on a second. Can I see your ID again?
Sure.
I'll let you look at your balances, but as soon as you start transferring money, and this isn't a two-factor auth thing. This is just you're in the lobby of the building, but now you're trying to get into a deeper area. So interesting. So that BitLocker.
Yeah, you can think of it as a click down, which is signing is pretty good. Knowing exactly the cryptographic hash of what should run on your machine is a level below, and that's sort of the difference between secure and trusted boot.
Okay. There's a really great video that I'll link to in the show notes where you were on Microsoft Mechanics. And what was really extraordinary about this video that everybody should watch is that you didn't just like show some slides. You spent the entire thing hacking actively into machines in multiple ways. Both I have the physical machine, like I've snuck into your house and stole it. And then I've done it remotely. But the ones that I worry about the most are like going back to my son's machine. It's just, he got a jar file from some country's website they shouldn't have been visiting, and it's running, and it's not like it's evil, but it's like a different kind of evil. Like what are you know what I'm saying? Like there's screw up your machine level malware, and then there's like state actor level malware. Maybe you could juxtapose the difference between those.
Sure. That is actually in some ways, I think, a mischaracterization of how things work. State-sponsored actors are happy to take the easiest path forward into your machine. They don't have a lot of pride in the craftsmanship. They're there to do a job, and if they can get you to be phished, or they can get you to click a macro, which is not, all of us have done a little Visual Basic script or things like that. They're happy to get in the easiest way possible. By nature, hackers are a little bit lazy, I can tell you, because I am one. So they're going to take the path of least resistance. So
really, somehow I thought it was fancy. Somehow I thought it had craftsmanship.
Now, if you make them get fancy, they will. So let's take, for example, why you would want to do, say, an early boot attack. Maybe that happens because you want to have stealth physical access, right? There's some interesting, there's been leaks in the past from, government attributed to governmental agencies where we can see they have hardware implants, or they use specialized hardware to do DMA attacks surreptitiously. Call that the evil cleaner attack. Someone sneaks into your hotel room, plugs a DMA device in, injects an implant, leaves. Those are all things that are real, can be done with less than $100 worth of hardware through toolkits like PCI Leech, etc. So those are real. There's also a form of attack, and we've seen that increasing lately, which is injecting into early boot, UEFI modules or modifying the master MBR boot for earlier sort of BIOS-based boots. And the goal there, in my opinion, is stealth, which is if you're dealing with a victim or a target who's got good visibility, has done all the right things, has Microsoft Defender endpoint protection, has application controlled, then it starts to make sense to say, I'd like to get in there before those security mechanisms, those agents on the machines are there. I'd like to sort of undermine the system. And in a way, whoever boots their code first wins, right, in the security race. And so that is where firmware and other things start to matter, right? It's in a way, it's like the stealth bomber, right? It's like, I could just evade radar. You could try to go fast. You might get shot down. You could deal with fighter planes, or you could just cruise through when no one knows, do your job, and you're out. And that's sort of what, firmware-based malware is at this point. I've run red teams for a long time at Microsoft. And they have a strong preference for that. Not only because it's cool, but because they know once they get in there, it's just game over. It's overmatch.
Really? Yeah, because if they're in there before your desktop comes in, if they're in there before the little circle starts spinning, then they're in. They're the person who's standing behind the door when you've opened your apartment. And at this point, your apartment is theirs.
And good systems engineering, people always ask me, they're like, hey, why are you so concerned about early boot and these other things? Why aren't you just reactively chasing malware X or VBS X? And it's like, in order for me to do those things effectively, I've got to build this house brick by brick. I need a strong foundation. I need the system at least to boot with integrity. Then I can bring up my kernel, my hypervisor, my drivers. Once I've brought those up, I can protect Microsoft Defender for endpoint. I can implement security policies. Going the other way doesn't make sense. If I implement security policies that are going to just be undermined with some simple vuln, that isn't really the way to architect systems either. And so I think people miss that, right? They sort of, and right, I understand intuitively, they sort of chase, like, fix this individual badness. They're not thinking about the engineering that needs to go into this type of thing. And what we're doing here is really building a foundation. And this sort of strategy or philosophy or a style of security is called trusted computing, right? You're building up this high integrity system, enabling you to have the control points that you need in order to solve those more direct problems.
Okay. So then when the tinfoil hats and the different people that are like, oh, we're looking to fill the landfills with old computers, and this is all just about, buying, selling chips and stuff. The computer that my partner uses works fine. I mean, she doesn't care. She'll use it until it finally dies. So I'm not going to toss it just because I can't upgrade to Windows 11.
No, I don't think so. And I think it's a little bit unfair to say that. I mean, people don't say that when the next generation of console happens or when the new video card happens, right? You don't say like, oh, this game is doing that. I think our goal, it's not like we're taking Windows 10 away. In fact, I would say if you're happy with Windows 10, it's providing a great security or gaming experience. It makes total sense to stay on there and get the value out of your hardware. I think our goal is just to make the next generation of operating system of Windows that people love, make it even better than ever. And this is the way we've had to implement that.
Getting things done is a challenge that everyone struggles with. One way to tackle it is to make sure that you have the right tools, and for your computer, that means the right apps. The problem is, not all apps do what they promise, and the drawn-out search for the right solution makes it harder to get the job done. That's why there's SetApp. SetApp is on a mission to help users get more done. With SetApp, there's no more worrying about having to search for apps to solve a problem. Instead, SetApp packs over 200 apps for your Mac and iPhone into one. There's an app for any task, so you can stay in your flow and finish what you started. With SetApp, you can think about your tasks, not your apps. A dedicated curation team only selects the highest quality apps, and new apps are added to SetApp regularly. Updates are free, and all the apps are full-featured pro versions. It's also a great value. Instead of paying thousands of dollars for separate licenses, there's just one flat monthly fee. Head over to setapp.com to try SetApp for a week. If you like SetApp, pay just $9.99 a month, as long as it's useful to you. And trust us, it will be. That's setapp.com, setapp.com. Before, you had said that a lot of these features already exist in Windows 10, and for a lot of people who weren't paying attention, it seems like 11 comes out, and it's got 9 different things and TPM, and it's like, well, hang on, it sounds like this has been actually something you've been working on for like a decade.
Yeah, Windows 10 actually required TPMs for any logo system. right? So for you to build a system that said like built for Windows 10, you would have to have a TPM enabled. And that dates in 2015. I think we first announced this requirement in something like 2012 or so, around the Windows 8 timeframe. And most Intel and AMD chips have included it for the last decade or so. So no, this isn't particularly new. And I think folks have gotten mixed up with the different factors: performance, reliability, security. From a security standpoint, I think most of what we're looking for there it's been well tread ground.
Yeah, I went and actually bought a new SSD at a local computer shop, because they actually still exist. And the guy asked me about my machine, and he was like, "Are you upgrading to Windows 11?" He's like, "Oh, you need to buy a TPM," and he had these little $14 TPMs.
Yeah.
But then I went and just Googled for it, and I was like, "Oh, I never turned it on."
Yeah.
And
a lot of people were surprised that it was there. Yeah, it's been there the whole time.
Yeah. It was funny to watch the prices on the little $14 Asus TPMs go from $14 to $100. The scalpers came out immediately trying to sell TPMs. I was like, you can turn it on. Most of you have it in the BIOS.
Yeah. The good news is that I think that went away just as quickly as it appeared, when people realized that was unnecessary. So
yeah. So speaking of things that have been around for a long time, I saw this tweet a couple of days ago where someone said that we've been running in a hypervisor. We've been running in a VM all this time. Like it's the Matrix. Have we been booting virtually? Are we running in a VM right now?
I'm not sure if I got that full context, but in a way, virtualization-based security does sort of run the system. I wouldn't describe it as like we para-virtualize everything in the conventional kind of Hyper-V way, but yeah.
I mean, we are
using virtualization-based extensions to create additional paging. We are fully segmenting code and data into a completely different sort of supervisor state. And so I guess you could think of it that way. Yeah. Well, I guess in a way, I think that's the right approach.
I think people were thinking that like Windows, like back in the day, you could boot off of VHD. So you were virtualizing the disk entirely. And I think simplistically, because again, it fits in a tweet, they were like, oh, well, Windows now is completely virtualized. But you're saying that like important stuff, individual processes, chunks of code, drivers, part of the system. So there's some pie chart of user mode and kernel mode. And huge chunks of it now are using not running in a VM, but rather using the virtualization instructions that the processor makes available.
Right. So the hypervisor will take advantage of or take control of things like the PTE, or the page table entries that manage what can be executed in either user or kernel mode. So it may take advantage of that. And by taking control of that, now it can apply policy. It can say, you need to prove to me you're signed before I'll flip these bits for you. You don't have access to these. Similarly with like MSR and ports and IO, all these security critical components on the operating system are now controlled by the hypervisor. And you could ask the hypervisor nicely, hey, secure kernel, can you help me with this or change this? But now it gets to apply policy. And so in that way,
read-only or security-based policy or whatever.
The way to think about it is, the old ring model, which is ring 3 is user mode, ring 0 is kernel. We've created ring -1, and we actually internally call it secure kernel. And we did that because in this giant monolithic kernel, where so many kernel drivers can be loaded, et cetera, we thought to make a modern security promise, we needed this additional sort of security boundary. And so that's what virtualization-based security gives us. And it's very cool. It has its own app model, right? You can run what we call trustlets in there. We have a bunch of different trustlets, some for attestation, some for things like credential protection to protect your NTLM credentials. And it's very extensible. It also works cross-architecture. We have it working on ARM. You can run on AMD, Intel, and whatever else new comes in the future.
Interesting. When I wanted to turn on virtualization-based security, I clicked the checkbox in Windows settings, and it gave me a list of all the things that I had to deal with before that. And a bunch of them were really old, funky drivers for all of my IoT devices. I've got a bunch of random stuff from overseas that you plug in, it installs, silicon, whatever, ST, blah, 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 unsigned kernel module. And it made me realize all the different times I'd plugged random USB devices into my system and got that little prompt that said, untrusted publisher, are you cool with that? And I was like, YOLO. And I had like 9 of them.
Yep.
And I just went through like one at a time, removing them from my drivers list before I could be secure. It made me realize I had a lot of stuff in my kernel.
You absolutely have a lot of stuff in your kernel. And it's one of those things that, with supply chain security being in this executive order and at the top of people's minds, it's become a viable way to hack millions of people, is to compromise an untrusted source, somebody who's not doing the right thing operationally. get a key piece of third party software. So, for example, I was a big Ultra Edit user a few years ago. They suffered a supply chain attack. I mean, imagine all the people who were using Ultra Edit for that day or grabbed an update being potentially targeted. That's the kind of the power of supply chain attacks. And we're talking about a kernel driver. Obviously, they're running at the highest possible privilege on the system before VBS anyways. It's a significant threat. And so that's one of the things, that VBS gives us the ability to do is curate what code actually runs the kernel and what certificates we trust.
My family has been watching The Blacklist, and then we started watching Fringe. And those are the two shows I think about the most, where they always have a computer person who ends up getting the laptop from the bad guy, and he plugs something into it and hacks in. And I always thought it was kind of cheesy, but then I saw you do it in this YouTube video. You plugged in something called a DMA device and basically went into the fingerprint driver and just said, return true, it's cool, whatever. Talk to me about these DMA devices and what's going on there.
The way that works is DMA is really cool because you can plug in a peripheral and you get high performance IO, right? Think about or external GPUs or camera devices. And we've had these peripheral standards for a long time. FireWire was quite popular. Now it's Thunderbolt's taking over, Express card ports. And so as like many things, they're great for utility and performance. They have some attack vectors from a security perspective. So any sort of DMA accessible port, whether it's M2, et cetera, unless it has an authentication mechanism, is usually going to be the potential for abuse if someone gets, even short-term access to your laptop. So traditionally, there's this document written a long time ago called the 10 Immutable Laws of Security that applied to Windows. And I think one of the first laws is if the computer is not in your possession, it's no longer yours. Basically meaning we can't guarantee that physical possession won't result in your machine being compromised. I'd like to change that. I'm not saying we're there yet, but we do have products like Xbox where that isn't true. And so we're taking a lot of the lessons learned there and applying them here. We also know that, maybe 10 years ago, this wasn't very accessible technology. Now with ASICs and FPGAs and a little bit of code from GitHub, you can build a PCI leech. I actually have several of them here. I brought mine to the show that are very powerful and less than $100 to build. And so essentially the way it works is when you have a DMA port that doesn't have any sort of authentication, you basically can map physical memory. And in this particular case, I was mapping memory of the biometric process and just patching out whatever I wanted. Old school hacking, right? Just like you pull a hex editor open. And so the way that we solve that is by using another hardware feature called the IOMMU, the input output memory manager unit. And that allows us to apply rules like say, hey, if the machine is locked, the IOMMU is going to shut off all DMA access for this particular region or to this particular device. You need to unlock your machine by using Windows Hello, et cetera, to add a new DMA device that would have physical access to memory, things like that.
I see. So that means if it's locked, you hit Window L and you walked away, right. Somebody comes over, they plug in a Thunderbolt, it's not unlocked, therefore it's not going to go up and detect that, and it's not going to do anything.
And VBS goes one level better with Windows Hello because if you've got a compatible camera, something we call it enhanced sign-in security, we move all of the code that does biometric matching from so-called normal world user mode into this VBS boundary, right, across that page table boundary. And so not only do you have the IMMU protecting you, but you have an additional memory region that's protected there. So that was what I was sort of trying to illustrate. And you always have these problem of like attacks are very abstract for people who haven't done this for a long time. And that's why I really like doing mechanics work with Jeremy. He always challenges me to take a really complex subject and break it down into these vignettes. Yeah. And then also do so in a way that doesn't freak people out, right? That you've got solutions. So it's kind of fun to be able to take what are actually relatively advanced cutting edge attacks and show them to folks. I think just at the Ignite, just before we broke for COVID, I did all that stuff live on stage. So that was that's by far the most challenging talk I've ever done, is just running all real demos, real exploits all at once on 4 or 5 machines in front of a crowd. And knock on wood, it went well.
That's awesome. One of the things that has been really interesting to me as someone who's a little I'm getting older and I've been around for a long time, is looking at the historical context of all of these things.
Sure.
So like DMA, which is one of the TLAs, the 3-letter acronyms we've been using, means direct memory access, right?
I'm full of those.
You just took a hold of this chunk of memory and you just decided to patch the function table and just say, I'm going to go ahead and take control of that. And DMA's been around since the 80s, late 70s. And when I was talking on Twitter with Anders Heilsberg, who invented Delphi. And one of the fun things I loved about Delphi is that you could do inline assembly.
Oh, yeah.
So you're writing in this wonderful high-level language, and you just take, SM, and now I'm poking into memory, just shoving into registers. We've come so far from a flat memory space to this layered security.
Multiple levels of indirection now and abstraction, definitely.
Yeah, and it works though. Why does it work? Is it working because it's standards? Like it's not just Microsoft making decisions; it's hardware vendors, it's motherboards, it's you working with the silicon people. Yeah,
well, all credit to our hypervisor team and some of those folks is the same technology we built for cloud that allow you to have what we call multi-tenancy, which is different customers who don't trust each other running on the same piece of hardware. It's the same exact premise here, right? We're just taking that battle-hardened code that we bet a pretty big cloud business on. And because we're Microsoft, we're able to shrink that, work with the exact same hardware vendors who gave us the features we need to do this on server onto client. So in a way, it's, from my perspective as a geeky person, I mean, this is a triumph. This is so cool. We shrunk down Azure technology and we used it for a very key problem, which is everyone's running at admin. So when you get compromised, people use that admin privilege to load something in the kernel and then it's game over. And what I'm trying to do is saying we cannot do that, right? It can't just be game over from you running as admin. We've got to create additional security boundaries here. And the way we're doing that is through virtualization-based security, which we know works because of the cloud.
Yeah, I think we've all had that text from non-technical parent, which is a photograph of the yes, no. Should I click on this?
Yes.
Is this? And then once they hit yes, it's just like, okay.
The good news is I feel like we've moved past that. That's one of the things I do all the time is, are we outsourcing this decision to the user? They're paying us to help them make the decisions on their behalf, right?
Yeah.
And that's one of the places I'm super excited about things like AI, which is, it used to be a very binary decision, right? I didn't have more context I could give you. Now we can use usage patterns. We can use context about the hardware, past behavior. Is this a developer style machine? We can infer that from the tools they have running. I mean, there's a lot more we can bring to bear to make good decisions.
Okay. So what I'm hearing you say is that it's much bigger than just a TPM or my CPU's fast enough. Does it have all of the different features? And there's a dozen plus of these features that you can get. It's a Windows 11 machine is going to be more secure. It's going to have better performance. It's going to blue screen or green screen a lot less.
That's right.
Like measurably less. You told me that you have millions of machine statistics that are showing that these are going to be much more reliable.
Yeah, we had a blog, I think in late August, where I think our reliability and performance teams did a great job of outlining what the decision points that went into that. So I'm not a performance person or a reliability person. At the same time, I'm fully supportive of us making the best possible experience. We do not want people having to choose between one of those three things. And so we got this thing to the point where it's like, you don't have to choose. If you meet this bar, you're going to have a great experience. Okay.
So here's the tough question as we end. And this is the question underneath the last question.
Yeah.
I see all these blogs that are like, go into the registry, change this, change that, and you can install Windows 11 in an unsupported way. Do I want, as the IT manager for my house, to encourage non-technical parent and my son and whatnot to go and install Windows 11 in that way? And what dragons lie beyond if they go and try to do that?
I mean, look, that's a support statement. So I think anybody who buys a product that they use every day is going to want to be able to get updates, work with folks, etc. I think we've made some statements on that. Certainly not my area of expertise. As a security person, I wouldn't advise you do that. If you've got hardware that runs 10, turn those features on in 10. But I think one of the great things about the Windows platform is that, it is open. People can have some choice there. So I think people are free to make their choices. But my personal advice would be go to a system that's supported, that's got everything that you need, it's been thought ahead and curated. And that's the direction I would go. But, people are free to do it as they like.
Okay, so then for folks that are running 10, they should run Windows security, click on device security, and there's going to be these choices like core isolation and security processor and secure boot. Turn on all those things, as many as you can, and it'll get you definitely better than you are today.
Yeah, and they have the wizard concept. If we run into a driver that's problematic, we'll let you know. That's not always as smooth as I would like, because running down drivers can't be great, but it's a place we're investing in. And then you get a lot of protection for that. You get this enhanced protected kernel. We block drivers now that we have the ability to sort of intercept and determine their versions and other things. We protect your credentials. We can help with DMA attacks. You get a lot of value for that.
Yeah. And I've actually written blog posts specifically on how to uninstall the drivers, which is hard.
I saw that.
I wish there was a UI, but there's some ways that you can do that. Because
I also pointed my team who works on those compat issues to your blog, and they did some reach out based on it. So
that's great.
The right things happen there.
Well, because Thanksgiving is upon us, and we all know what happens at Thanksgiving is you go to your family's house and you run Windows Update on your grandparents' machine.
Hey, this Thanksgiving, I think what I saw in the news is a few of the key processors are coming out. So I'm going to build a new machine because there's a new Warzone, there's a new Battlefield.
I've already pre-ordered the new COD. So
right.
I'll see you
awesome.
there.
All right,
brilliant. Thank you so much.
Quick plug too for you. If you play Warzone at all, I'm doing a charity tournament this Friday. So if you want to jump on, let me know.
Oh, very cool. Send me that.
I'm not great, so if you see me, I'll be an easy target.
Send me that, and I will tweet that. Okay.
Cool.
All right. Fantastic. We have been talking with David Weston, Director of Enterprise and OS Security at Microsoft, and this has been another episode of Hansel Minutes. And we'll see you again next week.